that we will have to learn is what Qt for MCUs package contents are, and what comes with installation of Qt for MCUs. We will go through all subdirectories of installation directory to understand which files are responsible for what and what directories contains. We will build and run application from the command line. This means we will go through the most basic way and the most raw way to compile and transfer your application to the board. This could be useful to fully understand how the build process looks like. Then we will go through the CMake APIs that are quite important thing. If it goes about Qt for MCUs, it provides you multiple ways to optimize your application and organize your application project. Then we will go in detail how Qt for MCUs application build process look like. You will understand how assets are converted, how fonts are then generated, and by which mechanisms your QML files are finally running on your board. And after those topics, we will have a short coffee break to get some rest, and we will get back to training with configuration of Qt Creator, which will lead us to first live coding session, first big live coding session, maybe let's say, in which we will see how to write application in Qt Creator and how to start developing your product. And after that, we'll have another break, which is the bigger one, the lunch break. So it will be the 1 hour one. And after that, we'll learn about assets and how to manage those. And I will follow up this with a live coding session to demonstrate the things we just learned. All right, and shortly about the second day, so about tomorrow's training, you will learn what is different between Qt for MCUs and the big Qt. You will learn how to style the controls like buttons, sliders, toggle buttons, and so on. The coffee break, we will see how to translate our application to different languages, and then, of course, another lunch break, and the C++ integration, which means how to connect your UI to actually C++ code. So how to connect the QML sources with your C++ sources. Of course, in between those, all of those topics, there will be another live coding sessions. So everything you will learn there will be also explained during the live coding session, maybe to have some more visibility how this really look like. All right, software requirements. Well, this presentation was made for Qt for MCUs 1.8, and the 1.9 was released just in a week. So there could be some problems with this presentation as I see right now. So there is a statement that Microsoft Windows 10 is the only supported operating system, but since 1.9, so currently Linux is also supported. macOS support is planned, but we don't know right now when it will be. And well, let me go through the other requirements other than operating systems. So Qt for MCUs, of course, 1.9 for this training. So the most recent one, Qt Creator, CMake, and the MSVC compiler to compile the host version of our Qt for MCUs application. But let me open the Qt maintenance tool to show you exactly what you have to click there to to get the proper environment. So after running the Qt maintenance tool or Qt installer, you have to log in, of course. Just click next after providing your credentials, then add or remove components. All right, please make sure that you have selected latest releases on the left side to make sure that the most recent things are visible for you. You can collapse the preview, and from the Qt, you can look into the developer and designer tools, where of course you will have Qt Creator, but it's by default selected. And what can be interesting for us from there, if you can scroll down, there is a CMake, which is the required thing. It's with a higher version that is needed, but it's fine. We will need Ninja to accelerate our CMake processing. And this is it from the tools, I think, from the big Qt. And then we can go to Qt for MCUs. Right, there is Qt for MCUs 1.9. And from there, we will need desktop MSVC. If you will expand this, and there's only a monotype Spark, which is selected by default. And for this training, this is the STM one. We will use STM32F769i discovery board. So you have to select the exactly this one for Qt for MCUs with a support for that board. Under this section, under this board, and as well under other boards that you can install, of course, you can install demo binaries, the compiler toolchain. I have both of them, so so the RMGCC and the IRR, and there is also a monotype Spark support. Let's collapse this. So from Qt for MCUs 1.9, you will need the desktop version and the STM32F769 Disco. And probably there's a question. There's no. Well, if I understand the question correctly, so you do not have the Linux host installation in the installer, and can you do anything about this? Well, you should have that. If you are running the Qt installer on the Linux host, you should have this option enabled. Just make sure that you have the latest releases and the Qt for MCUs 1.9. Right, from the Qt for MCUs section and the third-party tools and SDKs, what could be interesting for us is, of course, RMGCC 9, which is also installed together with the package here. And as we are using STM board, STMcube programmer, and STM32Cube F7 SDK, those are the things that are needed for this training if we are going to work with exactly this board. Of course, if you are going to use different board, you probably will need different SDK. All right, and this is it if it goes about Qt installation. So I will just click cancel. If you are going to install anything, you of course have to click next. All right, and another thing is to configure the MSVC compiler for the Windows, as this training is based on the Windows operating system. I will demonstrate you how to run Visual Studio installer and which things are needed from there. There is a question from Claudio, why I selected two versions of ARM GCC C++ from ARM C++ GCC. Well, let's say this is just because I have previously configured my environment for the Qt MCUs 1.8, and this was delivered with the older version, and right now 1.9 is delivered with the newer one, so I just have both installed because I have the previous one still present on my device. But normally you will just need the one. All right. Well, so this is a Visual Studio installer. And let's see what do you need from there. So on the example of Visual Studio Professional in 2019, let's click Modify and Individual Components. And right now you will have to select two things, MSVC and C. And let's search for the proper ones. So MSVC version 1.4.2, of course, for the correct architecture, 32 and 64 bits. And another thing is to install Windows 10 SDK. And just type Windows 10 in the search bar, and let's select the most recent one. And that's it. You just have to install those two things. If you're curious what could be needed as well, you can think about documentation, which is available online. Of course, it's also delivered as an offline version, but probably the most convenient thing will be to use that online. It's under doc.qt.io/Qt4MCUs. All right, this is it if it goes about software requirements. And right now, let's see what you are receiving after installation of Qt4MCUs. Of course, you will receive Qt Ultralite graphics runtime, Quick Ultralite graphics runtime, which is the heart and core of Qt4MCUs. This means this is the part that is common for all Qt4MCUs ports. If you are working, for example, with different STM boards, they will have a bit different platform adaptations, but they will have the same Quick Ultralite graphics runtime. This is the thing that is calculating all of the UI elements, positions, sizes, and it decides which parts of the screen needs update. And this calculates all of the animations, controls all the mechanics that is driving the whole Qt4MCUs. You will receive Qt Quick Controls library, which is a subset of Qt Quick Controls that you can know from the Big Qt. It also comes with default styles for them, and the mechanisms to provide theming, so you can override the default styles and provide your own. I mentioned that a bit before. Platform adaptation libraries that are the adaptations for particular hardware. Those platform adaptation libraries are then linked together with Quick Ultralite graphics runtime to provide rendering acceleration. If, for example, your device will have a GPU, and the platform adaptation will take care about transferring all the rendering requests from the Quick Ultralite graphics runtime to finally to the hardware, And the platform adaptation is every time different for every hardware you will have. So for example, different STM boards, you will have different platform adaptation libraries, and that accelerates your rendering in the most efficient way. You will receive development tools, which means Qt Creator with integration for it, and for example, the linguist tool to provide localization support. We will learn about those two during the live coding sessions. Offline documentation and examples with the source code is also delivered together with the package. And there is a question: can we have MSVC installed from Visual Studio 2017 version? From my experience, yes, it should work. Simply, it should work. All right. And the folder structure. So let me right now prepare for it. I will open the installation directory. All right, here it is. So this is the main Qt installation directory. Okay, there's a question. I can confirm this is how I've installed it. Okay, perfect. Thank you very much. All right. So this is the main Qt installation directory, and let's review what is important for us and for Qt for MCUs. And before I will start talking about Qt for MCUs package itself, let's look on the tools that we have also installed. So in the main Qt installation directory, let's search for the tools folder. Let's go inside. And the things that are important for us here is, of course, CMake, which is installed directly there. And Ninja tool is also installed here. And for example, Qt Creator is also in this directory. And there is also Qt MCUs subdirectory, which contains the things that are specific only for Qt for MCUs. And as you can see, this is the ARM-GCC directory with two versions, as one of you spotted during the previous environment setup, but only the one will be used. So in my case, the ARM-GCC 9. And for different vendors, there are also different tools that are installed together, or the SDKs, as in this case, for example, STMcube SDK for the F7 family is installed here, and Qt Programmer installer is also located in this directory. Let's get back to the main installation directory, and let's review Qt MCUs, which contains all versions of your Qt for MCUs installation. 1.8 is well, almost empty in my case, as I uninstalled this one before this training. We will use 1.9, which contains a lot of things. And let's review each of those directories. What are they important for? Why mean GW compiler is installed? It's currently not related to Qt for MCUs. It's also a thing that is related to my environment setup that was needed for the big Qt. And for different purposes done for Qt for MCUs. We are planning to add MinWG, MinGW support for Qt for MCUs, but we do not know when this will happen. But there is a plan to replace MSVC with this one in the future. But as I said, this is not related to Qt for MCUs right now. All right. Well, then let's review what comes exactly with installation of Qt for MCUs. So there is a bin directory which contains tools that are needed to compile your Qt for MCUs application. Those tools are responsible for example, converting QML code to C++, This is responsible as well for converting the assets and for generating the fonts, the glyphs, and so on. And also this directory contains some libraries from the big Qt that are needed to run your application on host machine. So you do not have to install the big Qt. You will just have to use those libraries that are located in this bin directory. And then you will be able to run your application on the host machine without flashing it each time you will change your UI. Compatibility directory contains some convenience implementation for some types that are not available in the big Qt, and those compatibility modules are, for example, for Qt Design Studio to provide you compatibility between the Qt for MCUs and big Qt. So if you have your application written for Qt for MCUs and you are using exclusive types there, then by using this compatibility module, you can, without any problems, run your application on the big Qt as well. Demo images, as the name indicates, contains images, precompiled images of demos for both bare metal and the FreeRTOS. And those are just simply demos that are ready for flashing on your device. And for each device you installed, you will have another set of precompiled binaries that you can immediately flash to your devices to test out how the things are working on this. Demos directory contains simply sources for those precompiled images. So you can compile those by yourself, or you can just look how the things were built. Docs, of course, documentation, but offline. Examples contains sources for simple applications. Well, for examples, as the name indicates as well. Those are small applications which presents particular features. You can see how particular features were used in more atomic way, and those are sources for those small applications that demonstrates some of the features. Include, of course, contains headers that are needed to compile the things properly. Kits are the files that are used by for example, Qt Creator. And kits defines what tools you have to use to compile your application for a particular target. And for example, in our case, if we are going to use ARM GCC for STM32F769i discovery for bare metal, we will use this kit, which is simply a JSON. And in this kit, we have a definition of the compiler, of the SDK, vendor, type of the board, and so on. The lib directory contains all of the Qt for MCUs libraries that are precompiled. And in this directory, you will find all the parts of Qt for MCUs precompiled to static libraries. And this means this is the Quick Ultralite engine. This is the platform adaptation. This is, for example, the monotype Spark integration, some charts, and so on. If you are going to use the PNG decoding, there is also a separate library for it, and this directory contains all of those. The platform subdirectory contains some specific code for the platform. So for something what is specific to the particular hardware. And for example, for F769i discovery bare metal, we have some different CMake configuration. We have the common directory for F7699 discovery, which contains some platform adaptation, and you can clearly see how the platform is built and how the platform is transferring all of the rendering to the hardware components. And then you are just sure that your implementation and Qt for MCUs implementation is doing exactly what you need. And if there is a need to modify this platform, for example, to support different LCD, this also a place probably where you will search for custom modifications. Plugins, so those are additional plugins for tools which provides support, for example, for different image formats. Source contains additional files that are typically shared between applications. For example, some third-party sources for monotype, or some common parts like default main entry function implementations that can be used in your application to speed up the prototyping process, for example. And util contains some utility files that are used by tooling around. All right, so this is about Qt for MCUs installation directory, and those are the things that are installed together with Qt for MCUs. I mentioned about this a bit before, and there's a thing that we call desktop backend, and this is a thing that is really useful in Qt for MCUs. Provides you a way to run your application on host machine. So if you are, as in my case, developing application using the Windows 10, you can run your application on Windows 10. And this uses the big Qt to render the things, your controls, images on the application window. And this is made to speed up the things simply. By running your application after you modify your QML files on the host machine, you are saving a lot of time. You will see in the next live coding sessions how application size and how application assets are causing longer and longer time of flashing our application to the target board. So to save some time, if you are just developing, for example, a single feature, to verify that alignment of some elements is proper, and then, for example, you can check for the colors and the assets and so on. You can do all of those things on the host, and then just verify, for example, the performance on the final hardware. And trust me, this is a much faster way of doing that, and this will be clearly visible during the live coding sessions. Of course, it currently uses MSVC compiler on the Windows. I mentioned that before, that there is a plan to transfer to MinGW in the future, but we don't know how. We don't know when it will happen finally. All right, so this is a time for creating the first application, and I will do that during the live coding session. And you will learn how to set up your CMake project. And in this part, you will see how to use command line to build your app, and then how to use the command line to run your app. And simply, let's get started with it. I'll prepare for it. All right, so I will open the terminal window. I will use the commander, but it can be any different one. So you can also use the default CMD from the Windows. This is not important thing here. And as you can see, currently I'm in some directory that is prepared for this training. Let's review the contents. I have some training materials. Oh, well, maybe this is the important thing. So currently you don't need that for this live coding session, but you will need some training materials in the further live coding sessions if you are going to follow those with me. And well, maybe I will try to share those with you. All right, my friend just write me that he will do that for us. So Jakub will share with you some training materials. I will explain you how those works in the next live coding session. And right now you don't need those, so you can follow these steps with me by just typing the same things on your side. So let's start. As I reviewed the training directory, there is also one with training materials that are going to be shared with you. And right now I'm creating the directory to keep all of the things of our first minimal application in the separate place. So make directory, first up. And let's go inside. And I will right now create a first QML file, which will define UI for our application. And I will use Visual Studio Code for it. And again, you can use anything what is more efficient for you. So code main.qml. This will open up a new window of Visual Studio Code. And let's try to define some UI. We will need import Qt Quick subset of the types. And I have to mention that the version in import is optional. Right now, I will just type it to be compliant with the next live coding sessions. Normally, it's not needed for Qt for MCUs, but it's needed for Qt Creator tool, for example, which will force you to provide this. And Qt Creator will need that to understand your imports, but Qt for MCUs will skip the version and always it will use the same, most recent one. So you just have to know that. All right, so we have import of the Qt Quick. Okay, but before we continue, there is a question. Why I'm using Visual Studio instead of Qt Creator? Well, so Visual Studio Code for this step is the more lightweight version, and in the next steps I will use Qt Creator. So just to not provide anything overcomplicated, it's just the most simple way to write the file. Qt Creator is a bit bigger tool, I think, so it's easier for me right now to use Visual Studio Code instead of Qt Creator. But as I said, in the next steps, I will use Qt Creator, and this is the only live coding session that uses something different. Right, let's continue with defining the UI, and I will create our app, the really simple one. So I would like to have the whole screen or whole app filled with the single color. So I will use rectangle as the root of our application, and I will provide some specific color for it, magenta. Right, let's save the file. Okay, and right now we will need the CMake file to define how to build our application. All right, once again, I will use the code for it. And I'm creating the file cmakelists.txt. Okay, we are redirected to Visual Studio Code, and right now we can start defining our application project. First thing, CMake minimum required conversion. This is not that important at this step. We have to define the project. Let's call it first up. First up. Oh well, there was a typo. And we will use C++. We need to find the Qt for MCUs package, and in CMake APIs, it's called QUL. So we have to find package QUL, right? So we have CMake minimum required version, we have a project defined, we have a package found. The next thing is to add the target to compile QUL, and this is the first place where we are using the QUL specific macros. And this is a Qt add target. It defines the compilation target for your application. And also it has a possibility to compile your app as a static library, but we are not covering that right now. I will talk about this later on. So we are creating a target first app. And right now we have to tie up the QML file with our project and with our target. And there is another QUL function for it, QUL target QML sources. And for the first app, we are adding main.qml. All right. And at this point, we have almost everything defined. And you can wonder, where is the main entry point for our application? And there are two ways of doing that. We can define this by our own, by just creating another C++ file, and by defining the main function there and running few functions to just initialize Qt for MCUs, and then we can start executing our application. But the most simple way of doing that on the first step is to use one of the predefined main entry points. And we can do that by using one of the Qt for MCUs macros as well. And this is app target default entry point. And this entry point is for target first app. And we have to provide the root QML file for our application. And in our case, it's the main, and we are providing that without the QML extension. Probably some of you just spotted that I used some macros that are starting with a QUL, and this one is starting with an app. And this is not a mistake. This is by design. So all of the QUL, prefixed macros are the things that are crucial for Qt for MCUs project, and all of the app, all of those macros that are starting with app are the optional things that can be just simply removed and replaced with your own implementation without any problems. So just to make it more visible, those optional are starting with app, and those required are starting with QUL. And you probably, it won't be probably that easy with removing those needed. Let's save the file. And right now we have everything ready to compile our application. Let's get back to terminal, and I will create another directory for build. Let's review what do we have here. Okay, we have both files just. Well, okay. So I will define right now some environment variables maybe before creating a build directory. So first of all, we need some environment variable that will tell where the Qt for MCUs installation directory is. And to do this, we are defining qul_dir, which will point to Qt root direction. This will point to Qt root installation directory, then Qt MCUs and the version, which is 1.9 in our case. All right, and we need CMake. So let's verify if we have any. We do not. So let's extend the path to make it visible for the terminal. Set path. Preserve the previous path. Semicolon. All right, and we will use the CMake, which is delivered together with Qt installation. Tools, CMake, in. All right, let's verify. And we have CMake visible right now. So let's try to generate the build target and let's build the application for the host machine. I create directory for desktop. I'm going to that directory and let's trigger CMake for the parent directory with the platform, Qt platform. This Qt platform variable is defining for which platform we are compiling our application. And for the host, it's just a Qt, as it's based on the big Qt. Let's provide architecture x64, and let's try to run. All right, so we have our application target generated properly. So right now we can try to build our application. And to do this, we are also using CMake, build this directory for target first, up, and for the release. Okay, there is a typo, not blue, but build. All right, so application is right now built properly. Let's try to run. And it's not running. It's a correct behavior right now. And I'm going to explain you why. So right now, there is system has reported that it cannot find the Qt libraries that are needed to run our application. And those libraries are exactly those which I showed you before during the installation directory review. And we have to extend the path with a directory that holds those libraries to make system able to find those libraries. And this is the normal way of doing this in the on the Windows. So let's extend the path. Let's extend the path by once again preserving the previous content of it, semicolon, and qul_dir, which we have defined before. All right, let's verify. And perfect, we have our application running on the host machine, and it's exactly how we defined it. It's a rectangle with a magenta color. And there is some message on the chat. Okay. All right, now Jakub has sent the materials for you, but I think for panelists, so I will just resend it for attendees as well. Okay, thank you, Jakub, for sharing the materials with us. And right now you should be able to download those from the Dropbox, and the link should be visible for you on the chat. So just please download those in the meantime. This could be needed in the later live coding sessions. And there is a question: can you show two path variables you added again? Yeah, sure. So this is the first one. So maybe let's copy this. I will send you those in the answer to your question. So this is the first one. And this is the second one. And there was only those two, I think. All right, so I'm sending you those two path variables as an answer to your question in the Q&A section. So you should be able to copy those on your environment. All right, so this was for the host, and right now we will try to run it on the real hardware. And please notice that I won't modify anything in our application project and sources. Let's get back to the root directory, and let's create another build directory for STM board. Go inside. Perfect. And what do we have right now? So compilation for the hardware is a bit different. So we will need additional environment setup for it. And first of all, we have to define ARM-GCC toolchain directory, ARM-GCC build. It's also delivered with Qt installations, so we will point this to C Qt tools, Qt MCUs, ARM-GCC 9, right? And we will extend the path once again with the path to the Ninja by preserving the previous path. And let's point this to Ninja that also comes with Qt tools Ninja. All right, let's verify that Ninja works. Perfect. Okay, there is another question. What does exactly Ninja do? So this is a generator for the CMake. Well, it does the processing of the files during the compilation, and it also provides you a way to compile your application in the faster way, as it supports, for example, the multi-threaded compilation. So this is just a bit of a help for us to simplify the command line commands. It's an improvement for compilation time. Well, simply those two things are most important things, I think, right now. You will see how triggering a build is different in a minute. But in general, you can live without the Ninja. It's not mandatory thing. It's just for the training purposes to demonstrate that you can use this with Qt for MCUs. All right, so we are in the STM build directory. We have the environment setup. So right now, let's generate targets for STM board. And I'm triggering a CMake for the parent directory, so for our application. We are providing Q platform, which right now will be different as we are using a board, not the host right now. So STM32F7 69i dash discovery dash bare metal. And let's notice that we are providing also the operating system there. Well, in this case, no operating system as it's a bare metal, but if you're, for example, going to use the FreeRTOS or any other operating system, you will then provide this in your Qt platform. Let's define the release build, CMake build type release. All right, we have to tell that we are going to use different compiler. So we have to provide a toolchain file for the CMake. CMake toolchain file. All right, and those toolchain files for particular compilers are delivered together with Qt for MCUs. So you just have to point this from the Qt for MCUs installation directory, and we will use our dir environment variable that we have defined before. And toolchains are located in lib CMake toolchain, and this is called arm gcc CMake. All right, and let's tell CMake that we are going to use Ninja as a generator for the targets, and that should be it. Let's verify if everything is fine. All right, it seems it is. So you can review the output right now. So toolchain was detected properly, and CMake has verified the compiler also properly. There is a QLDIR which points exactly to our Qt for MCUs installation directory. So it seems that we are ready for compilation of our application. And to do this, as we are using Ninja right now, it's more simple than previously. We do not have to provide that full long command to tell that we are going to build this directory and then selecting the target with different arguments. We just have to call Ninja with our target, Ninja first, and that's it. We have to just wait a bit. And here it is. So the whole compilation is more tightly coupled with 2 lines. We also do not have that full log of a build. So this is another thing that Ninja can be used for. But well, let's get back to the topic. Well, so currently we have built our application, but you can wonder how to transfer this application to your device using the Qt for MCUs, but because this is possible. Before I will do that, I will just show you what is currently on the device by sharing with you view from the secondary camera. So, well, you can see right now this is my hand, so this is not the recording. Okay, there's a question, maybe let's answer this. You've mentioned it at the beginning, but I want to be sure. Must I know QML to use Qt for MCUs? Well, yes. QML is the way that QML is the way how you define the UI for your application in Qt for MCUs. So you have to know that. But during those live coding sessions, I will show you everything step by step. So if you are going to follow me on live coding sessions, it will be enough. You probably won't have to know that much, but in general, if you are going to develop the application, then you have to know QML. Right. So just to show you that right now application is the board right now is just showing the some content from the memory. This is anything that is useful for us. This is just some garbage that is located in the place that the board is expecting to have the frame buffer for the LCD, and we are going to change that. Let's get back to sharing the screen, and to transfer our application to the to the hardware, I just have to call one of the flash targets that are prepared by Qt for MCUs. And this looks like this: Ninja flash underscore first up. And this target is added automatically if you have installed the Qt programmer during the environment setup. Qt for MCUs automatically detects that you have installed the programmer for the board and creates additional flash target for you, which does all of the things for you implicitly. You do not have to worry about how to transfer your application and your binary to the board. And right now I'm going just click enter, and I will switch view to secondary camera once more to show you that application has been transferred to the hardware. So I'm just hitting the enter, and I'm switching the view to the secondary camera. So still, this is my hand. This is not the video. Let's wait a bit. Application will start flashing in a second. You can see maybe that the LED near the cable were flashing for a while, and here it is. And this is our, well, let's trust me. I always have to say that the camera is not the best quality, so you probably can see the blue screen, but trust me, it's the magenta one on my side. So our application is right now transferred exactly in the way we have defined it to the board by just calling one target from the CMake. And you can review the output from the flashing, how this was looking while I was showing you the secondary camera. So there is some output from STM32Cube programmer, and there is some progress of downloading your application. So even if you will encounter any problems, you will be able to review what is exactly the problem on your side by reviewing this output. Do you have any questions to this part, to the compilation of our application in the command line? Maybe you are still missing some environment setup, some paths and some environment variables. Is it possible to use STMicroelectronics programmer to transfer to the file to MCU? Yes, just as I said before, Qt for MCUs is using STCube programmer under the hood to transfer this application. It just covers STMicroelectronics programmer it covers it in this flash target. As you can see, I just run this flash underscore first up target, and under the hood, this target is running the STCube programmer to flash our board. Even if you are looking carefully, there is an output from the STMicroelectronics programmer. So in general, it's using it. You can also, of course, you can also use this by your own, but it will be a bit harder, I think. Well, I can even show you that there is. Well, let's open the first up build STM directory release, and here you can find the ELF and the hex files that you can also use by your own to flash the board with STCube programmer. But well, I'm not sure if you are going to do this as a first step, as just using the Ninja flash target is a simpler thing. I also see that Jakub is pasting some answer for you, so just let's wait a bit for him, and probably everything will be more clear then. And let me go further with our presentation. So this is the end of the first live coding session, and let's sum up those things. So to configure your command line setup, you have to, of course, create a separate directory for your application where you will hold your QML files and the CMake configuration. you have to define the QDIR environment variable to tell your operating system and Qt for MCUs where the files from Qt for MCUs are located. To compile the things for the host, you have to create a separate directory for the build. Then you are triggering the CMake with Qt platform Qt, and this will generate your targets to compile your app for the host machine. You can, of course, trigger it with that typical CMake syntax for compilation. And to run your app, you have to tell your operating system where the Qt dynamic libraries are located in your installation by extending the path with that directory, and then you can run your app by just simply running the exe file, which is the result of compilation. For the hardware, of course, there is just a need to define the variable for the toolchain, for the compiler that you are going to use with it. And then you can also generate CMake targets, compile it, and flash the board by using our flash targets, or by your own way. It's also possible to flash the ELF files separately with your own solution. Well, we were using some CMake APIs during the first live coding session, but those were not explained, and those were rather only a few of them. So let's right now focus on those and on different CMake APIs and what those are doing for your app and for us. So first of all, the Qt platform argument for the CMake, it holds the target platform. It defines for which board you are going to compile your application, and this is causing that finally the app will be linked with a different backend. So for the STM32F769i, it will have a different platform backend linked than for Qt, which is also a default thing. And by switching this value, you are simply switching the platform that is your target for the particular compilation. Qt color depth is defining the target color depth for the display, and this must be one of the 8, 16, 24, or 32 values. And well, in the most cases, it also defines the frame buffer format. So by lowering the value of this parameter, you are also lowering the amount of memory that is allocated for the frame buffer. But some of the platforms that are supporting the hardware layers are using this value just as a default value for the layer, as this can be overridden in the QML then. QLab target macro is a thing that we were using in our first application. Okay, there is a question, so let's pause. Is it possible to run on the FreeRTOS instead of bare metal just by changing the target? Yes, it's possible. It's exactly how it's done. You are just changing the platform to STM32F769i -discovery-FreeRTOS, and that's it. You just have to recompile your app. Any more steps are needed. All right, so QLab target defines the target for your application, and also it defines what your application has to link. So it automatically links Qt Quick Ultralite libraries to your target, and also it provides you a way to create a static library instead of the binary. This can be useful if you are going to create the big application, big environment, so maybe ecosystem, and Qt for MCUs in this ecosystem is going to be just a module. Then you can use that static library flag to just compile your application as another library that you will link finally to your big app. But this is a more advanced thing probably. Some example is below. So how to define the example app with two sources? Well, it also supports providing the C++ sources. What would happen in the case? There is a question. What would happen in a case the color depth configure is not supported by the hardware? Typically, it will cause the compilation error, so you will be informed. So this is simple as it. And well, for the platforms that are supporting the layers, it will fall back to the closest possible. But this is something that will be this is something that will be clearly visible in the platform sources, so you can always verify. What will happen for such platforms, but normally it will cause the compilation error for these simple boards, and for the more advanced with a layers support. Well, there will be a fallback to the closest. How to add the QML files to your project? There is a macro Qt target QML sources. You're providing the target from the CMake and the list of the QML files that you are going to add to your application. It also supports some optional arguments like output directory. And this will mean this will change the default directory in which the artifacts for the compilation will be held. You can use, well, you shouldn't use that. There is a module URI argument, which is a deprecated API to define the modules. This is the old way and shouldn't be longer used. And there is also a copy QML files optional arguments, which will tell our build process to copy source QML files to the output directory. This can be useful if you are going to use your QML files in some modules. Application entry point. So those are those utility, maybe not utility, convenience macros that you can use to speed up the development process, some prototyping process. You can define default entry point by just calling one of those, or both of them in the same time. App target default entry point defines default entry point for your target. And also it takes an additional argument with root item, which defines the root QML file for your whole application. And this will depend on the OS which is selected. If you are compiling for a different FreeRTOS and for the bare metal, this macro will do something a bit different. As for the FreeRTOS, it will pick a different entry point, which will also initialize the FreeRTOS things next to the Qt for MCUs. And app target setup OS is convenience macro to define your operating system in the CMake, and it will then set up some allocators and so on for your app. Previously, I said that there was a deprecated API for defining the modules, and this is the modern and the current way of doing this. There is a separate macro for it. Qt add QML module for the target, which will be a separate target for your module, of course. Defines the separate static library that will hold your module separately. And let's review the arguments. URI will define the URI, which will be then used in other QML files to import your module. List of QML files, of course, to define your module things inside. The headers, if there are any. Sources, if there are any. You can also provide the imports that your module is requires. and output directory to redirect the compilation artifacts. It's also the important macro, as it's a required thing to define the singletons. So if you are going to create a singleton in the QML that you would like to have in your whole application, then you have to use that that macro to define that singletons. Qt add resource is a macro for adding assets. If you are going to add some images, you are going to use this macro. And how this looks like, it just picks, of course, the target, list of the files. There are two optional arguments prefixed in the base to manipulate how you reference your files then in the QML, but I will cover those later on during the resource topic explanation. Of course, the output directory can be changed by providing a different path. For translations, there is a one macro, Qt target embed translations. This define translation for your target, and also it creates some additional CMake targets to generate missing translations, but this also will be covered later on more in detail during the topic of translating your application. And finally, to integrate your application with the C++, you are going to use Qt target generate interfaces, and this macro is taking of course the target and the source files, which are typically the headers that holds the definition of C++ classes that are then converted to the QML interfaces, and this provides you a way to connect the QML and the C++ together. Some properties related to fonts. There is a Qt fonts dir. This simply defines where the fonts that you are going to use are located. By default, it points to source third-party fonts subdirectory. If we are moving from the Qt MCUs installation directory, and Qt default font family defines the default font family for the whole application. And by using this argument, you're able to change the fonts for whole application globally instead of modifying each font.family property for text or the static text components. By default, it's a deja vu sans. Some resource-related properties. The Qt texture cache, it's the really important property, and we have to focus right now. So this defines the maximum image cache size in bytes. It also has to be set before calling add executable. And why it's needed and why it's important and what it does. So there is a concept of image cache, and it's used for multiple things, but let's focus on some example. For if you are going to use compressed images in your application, so you are flashing your application with assets in the compressed format, for example, as a PNGs. Then during the rendering, you have to decompress those images for some time. At least for time of blending or blinking this image to the frame buffer, and some space has to be prepared to keep that uncompressed image for a while. And this is what image cache does. It just holds some space for such dynamic cases where you have to or would like to decompress something or put something to cache for the faster access. And we are, by providing the Qt texture cache property, defining how big that image cache is. And it must be set to at least the size of the biggest decompressed image to be cached. It's because If it will be lower, then that image cannot be decompressed properly, and your application will just halt. And from the other side, if you will set this value to big one, you can overlap some other things in the memory, and well, the behavior will be undefined. So this has to be used with a special care, and we have to keep in mind that the size of the texture cache has to be at least of the size of the biggest decompressed image, but it cannot be too high to prevent some malfunction of your application. There are some additional CMake options for debugging, so you can enable bytecode debugging by enabling the QL debug bytecode. It will generate the JavaScript bytecode for the QML functions and as a comment to the right side of the code. Also, there is a QL debug line directives, and if you will enable that one, it will generate the line directives, which will point back to QML source. So if you are then debugging your application, your debugger will be redirected to the QML files instead of the C++ files to see where you are exactly in your UI code. By default, is disabled, and the line directives are generated as comments. So still, if you are not using it, you can review and point back manually to some QML lines. All right. So this is about the CMake APIs, and right now we are moving to the Qt for MCUs build process. And this is a quite complicated thing, but we'll try to explain all of those things to make sure that every of us understand how particular steps look like and what are responsible for. So we will be going on this diagram from the top left corner to the bottom of it. So the first thing that will happen is, of course, the root CMake list.txt file, which defines your CMake project at all. So everything that will happen with your application in the compilation process is defined in your CMake lists.txt. And well, the next step is to compile the images, if there are any, for your application. So if you have any assets in your app, they will be prepared by the tool called QLRCC. And what it will do with those assets, it will convert those assets to the binary form, to the bitmaps, or to the compressed formats known by Qt for MCUs. Depends on what are your needs defined in the CMake lists.txt. Those bitmaps will be just a C++ files with normal arrays with a bytes, which will be then added to the compilation. And the next step is to compile the fonts. So the Qt font compiler will go through all of your QML files, will take your font file and will generate the fonts as alpha maps. So in general, as a bitmaps as well, but in the alpha formats that will hold just the transparency for the pixels to save some memory. But in general, Qt font compiler is the second step of compilation. It will generate the glyphs for the text that is used in your app. So it will only generate the glyphs for characters that are really used in your app. You can, of course, extend the range of the glyphs by using some other mechanics, but we'll cover that later on. The third step is to generate interfaces, and it's done by Qt interface generator tool. It takes the headers, the C++ headers of C++ classes, and it translates those C++ classes to the QML files, to the intermediate QML files that are then passed to the next step together with your QML files. So your UI definition that is held in your application directory together with those intermediate QML files for interfaces to connect your C++ with QML are going together to Qt CPP tool, which converts all of the QML code to C++. So finally, you are not running QML interpreter on your hardware. You are just running the C++ code, which is the much faster thing for the microcontrollers. And finally, all of those auto-generated C++ files. So the bitmaps with the arrays of the bytes for the images, for the fonts, the C++ files after QML conversion, together with your C++ files, are compiled and linked to final binary. So this is how Qt for MCUs prepares and then compiles all of the things for the host. Does that mean that indirectly header files are converted to CPP? I'm guessing that you are talking about the part of Qt interface generator. No, it does not mean that. Those header files in the step Qt interface generator, those header files are converted to the intermediate QML files, but QML to CPP is able to detect that those are QML files that are intermediate, and it will not generate additional C++ files for those. It will use your C++ implementation for those headers. So this is just to make Qt to CPP, let's say, happy, and to tell that those QML types are going to be implemented by developer of the application. So there is no indirect conversion of headers to C++. All right. Well, so this was in overall how the build process looked like, and right now let's focus on the tools itself. QLRCC is let's get back. QLRCC is a tool to convert the images to C++. As I said, it follows desired policies. So if you are going to have images in the compressed format on your hardware, it will just recompress those to the formats known by Qt for MCUs. It will also follow desired resource loading policy. So it will hold the information if your image is to be read from flash or it has to be copied to RAM. It can optimize the image for graphical transformation. It will generate the C++ as an output with a C++ byte array, and depends on the compression. It can be a compressed byte array, or it can be a normal bitmap of a given format. It also has a pretty good way of optimization of semi-transparent images. Let's imagine the case where you are, for example, displaying some gouges, so rounded gouges that are mostly the frames, and let's say 80% of the image is completely transparent. And this tool is able to cut that parts and compose your image with a smaller pieces of it to save some memory for you. Qt Font Compiler is a tool responsible, as I said also before, it's responsible for converting the fonts to C++ byte representation. It generates the glyphs and stores that arrays as pre-rendered alpha maps. It will also detect how and which glyphs are used in your application, and will generate glyphs only for those characters that are used in your app. You can overwrite and extend range that is used to generate glyphs. So you have the full control of what this tool generates for you. QML interface generator is a thing to generate interfaces from the C++ to QML. This will be covered in detail. Really in detail tomorrow. But in general, this is the way of generating the interfaces to connect your QML with your C++. For example, if you are going to get some input from the user, and based on that input, you are going to trigger some hardware. For example, I don't know, connect to the Wi-Fi or trigger some pump or something. So then you can connect your QML and transfer those events to the C++, and based on that you can from the C++ manipulate some hardware by calling some BSP functions. And well, there is a question: are all the resources, images, fonts loaded at the same time as the executable, or they are lazy loaded? Oh well, so this can be done as you wish in general. So if by default all of the assets are just located on the flash. So during the rendering, the GPU or some accelerator is just reading the pixels of those images, fonts, and so on from the flash. And if you are going to load this to the RAM, you can also define that. You can tell Qt for MCUs that hey, listen, I'm going to have those files in the RAM, and Qt for MCUs will load those images during the startup to the RAM, but only those that you are selecting for this. The other way is that they are lazy loaded. For example, if you are going to use compression, so if your images are compressed, then they will be loaded and decompressed in the lazy way. So this depends on the properties that you are setting on your images. So normally this is not loaded at all. It's just lying on the flash, and it's read it directly from there. And you can decide if you are going to load those on the startup to the RAM. And if you have the compressed format of the images, they are then lazy loaded to the image cache. And once the image cache is full, it will free some old resources from there and will load again the most recent files for you. Just let me know if that answers your question fully. Well, so getting back to QML interface generator, well, it's used basically to convert the header files of C++ classes to QML intermediate files for the you're welcome for the compilation process, and forwards all of the properties, signals, and functions to QML. So if your class contains properties, signals, or the functions, it will be transferred to QML and will be accessible from the QML as well. QML to CPP, simply it converts every QML file to CPP. It also adds some initialization code to your app. So your C++, your intermediate auto-generated C++ files are ready to go. They are transparent for you. All the initialization and stuff required to allocate your classes is also generated, so you don't have to care about those. Well, and as I said, it's also smart enough to detect which QML files are the QML files that are intermediate for the interfaces, and then it does not create any C++ sources for it. It just uses those to understand the relation between some QML components. Well, there is a question. Does QML understand C++ stuff? For example, functions that return unique or shared pointers. Well, not that much. So QML will understand some basic types, and I will also cover that in the part that will cover the whole C++ integration with the QML. But basically, it just understands the most basic types like a bool, integer, some floating types. You can also return other complex types, but those has also to be interfaces that are exported. So in general, you can mimic some behaviors, but not all of the types are supported. For sure, the unique or the shared pointer won't be supported out of the box. Well, so this is about QML to CPP. Well, just maybe let's agree on the simple rule. If my answer is really answering your question, just please let me know. So I'm sure that there is nothing more that you're interested in. And if there are still some unclear things after my answer, just let me know in the Q&A section by adding additional question for it. Then we will be sure that we are not missing anything there. Sometimes it's hard for me to understand the question fully. Maybe it will be easier for us to get some feedback. So just please let's agree on that. If my answer is answering your question, let me know in Q&A section that okay, it's fine, or just let me know it's not enough for you, and we'll try to dig in more. Thank you very much. So, well, let's go further with the presentation, and this is the time for coffee break. So just before we go to the coffee break, there is a time for additional questions, maybe to the some previous parts of this training. Some things maybe are still unclear and or in your head. So this is a moment for clarifying that. In the meantime, I will prepare timer for 15 minutes. I will wait a bit for maybe possible questions. All right, I don't see any. So let's see each other in 15 minutes. And let's have a get the great coffee and see each other in those 15 minutes. All right. Welcome back after the short coffee break. And let's continue with the topics on our today's training. And the first thing after the break is the Qt Creator configuration. And let me open Qt Creator to show you exactly what needs to be done there to work with Qt for MCUs. Just please wait a bit. Qt Creator is opening. All right, you should be able to see the Qt Creator right now. This is the window from my operating system. First of all, let's verify if we have the appropriate version. So let's go to help, about Qt Creator. And if it's 4.15, it's fine. Next thing to do is to verify if we have Qt for MCUs plugin installed and running. And once again, let's go to help, about plugins. In the filter field, let's type MCU. And if everything is fine on your side, you will find the MCU support there under device support. It should be selected under the load. And if there is also a green tick, everything is fine. It should be automatically installed and enabled if you are using Qt for MCUs. So no special configuration is needed there. You just have to make sure it's properly loaded here. Okay, now let's verify if we have everything ready, if it goes about compilation and configuration. Open Tools, Options. Enlarge it a bit, and let's go to the bottom of the left side scroll menu to Devices, and then in MCU tab, let's verify the things there. So first of all, sorry about this. First of all, you should have Qt for MCUs directory, installation directory provided in that text box. It should point to your Qt root directory and then Qt MCUs and the version of the Qt for MCUs 1.9. There should be a green tick that verifies if the path is valid by checking if QML to CPP tool is found. On my side, everything is okay, so it should be exactly the same on yours. And below, you can review what targets are supported by your Qt for MCUs installation. On my side is Qt for MCUs 1.9 for desktop and for the STM32F769i discovery for bare metal and for FreeRTOS with two different compilers. And let's maybe review what's under the bare metal for ARM-GCC. We can verify that toolchain used there is the proper one, so ARM-GCC 9. It's also verified by checking the bin directory of the toolchain if ARM non-EABI G++ exe was found. Also, it verifies if STM32Cube programmer is installed and it properly founds the installation. And SDK is also located in Qt installation directory under the tools Qt MCUs STM. So this should be exactly the same on your side, maybe with that difference. If you have installed Qt in different place, the paths will differ a bit, but in general, it should look almost the same. And all of those kits should be automatically detected in the kits section. So once again, let's go to the left side to the scroll view and go to the top of it and to kits. And here you should be able to see all auto-detected kits for your Qt for MCUs configuration. And we have a question. Will there be support in the future for Kyle, ARM, and DK as well? Currently it's in our backlog, but it rather has a low priority. But for sure, if it will be needed for any of our customers, the priority will be higher. But currently there is no support for it. But we are aware of such a compiler and such a toolchain. So if there will be any need for it, for sure it will be added. But currently we are focusing on providing more features to the platform. We are not extending the compilers at this point. But as I said, if it will become more important for any of our customers, for sure it will have a higher priority. And there is another question. What is different between desktop kit and Qt for MCUs desktop? So those are completely different things. Desktop Qt is, let's say, the big Qt. As you probably know, the big Qt. So this is a normal Qt that was existing before. And Qt for MCUs is a completely new product, and the whole mechanics, whole engine is written from the scratch. And Qt for MCUs differs at different levels, but the first level of a difference, I would say, is a difference of a product itself. It's a different code. It's a different engine. It works in a different way. It shares some concepts, and from the QML perspective, it's compatible, but under the hood, it works differently. So this is the main difference. This is the main difference, and Qt for MCUs target is using the big Qt to render the things on the host. So, Qt for MCUs target also is using the CMake APIs that comes together with Qt for MCUs. It follows the configuration of Qt for MCUs. It follows the policies for the resources. It follows the rules that are for compilation of the assets, of the fonts, and so on. So it's a completely different thing. If you are going to work with Qt for MCUs, you have to use Qt for MCUs desktop target, and the desktop Qt kit is even a problematic thing. You cannot mix them that simple. Let's treat that as a completely different thing. So if you are going to work with MCUs version of Qt, you just have to use Qt for MCUs targets. All right. So those are automatically detected kits for Qt Creator, and let's review those. Besides those things that should be more or less the same on your side, just make sure that we are using the CMake tool there that is delivered with Qt. Sometimes Qt Creator is detecting the system CMake as a default one, so just make sure that CMake tool here is selected to that one marked with Qt in the braces. So we have exactly the same environment on my and on your side. And this was for the desktop. Let's verify bare metal for ARM GCC for STM32F769 discovery. And just make sure that besides those things that should be valid, if you verified that on the devices section, the CMake tool has to be selected to that one delivered together with Qt. And just press OK if you made any changes. Okay, there is another question. Why Microsoft Visual Studio has to be installed? What compiler is used to compile the MCU code actually? Well, so Microsoft Visual Studio has to be installed to provide MSVC compiler, so compiler from the Microsoft. And this compiler is used to compile your application for the host machine and to run it on your device that you're using to develop your product. So, for example, if you have the Windows 10 instance and you're working on Windows 10, MSVC is used to compile your Qt FrameSUS application and verify that one on Windows 10. And for the hardware, so for the STM board, we are switching the compiler to ARM-GCC or for the IRR or for any other that you are going to use with it. So Visual Studio compiler and Visual Studio has to be installed just for compilation for the desktop, for the host, to verify your application on the host, to save some time for flashing, for example. And for the boards, of course, you are using cross compilers, as this is a different architecture. So this is the difference. All right. So this is about compilers itself. And maybe let's try to verify if the setup works. So after verifying that all of those things we just reviewed are valid, let's now verify it by creating some example application. And to do that, let's go to the left side to the welcome page, to the projects, and let's create new. Okay, before that we have a question. If we use MSVC means not using CMake. No, it does not mean that. CMake will use MSVC to compile. CMake is not a compiler itself. CMake is just using some environment variables, some compilers, some tool chains to provide you an easy way to compile and to manage your project. But you can always switch the compiler in CMake. So CMake is just to keep your build environment tidy, and it can use MSVC, it can use ARM, it can use ARM-GCC and other compilers as well. If it's only for prototyping, can I rather use my preferred compiler instead of MS Visual Studio, in example C-Line? Well, in general, yes, but it's not tested and it's not prepared, so we do not recommend that. It probably won't work out of the box, so you will have to provide some modifications to Qt FrameSUS. So in general, technically it's possible, but we do not recommend doing that. So it's recommended to use MSVC compiler for now. In the future, there will be a different compiler, MinGW supported, but as I said, we do not know the exact date for it. And also, I think Jakub, my friend, has answered your question in the text form. All right, so let's create another project. So example one, let's click application, Qt FrameSUS. Let's select the only thing in the center part of it, MCU support application, and let's click choose. In the name, let's name it Hello World. I will switch directory to our training directory, which is on desktop. All right, click next. Let's verify if we have selected anything. The WebAssembly is selected on my side by default, so please unselect anything what is by default selected, and let's search for Qt FrameSUS, and we are going to select desktop and STM32F769i Discovery Bare Metal for ARM-GCC. And next. We are not going to use any version control, so just click finish. All right, so what do we have in our example project? We have some basic Hello World QML, which is just a rectangle with some size. And there is also a text which is centered of the screen. Rectangle will be a white one. It's the size of the rectangle is smaller than the screen of our application, so I will remove the size to have it full screen. And well, maybe before running it, let's see what question we have. Okay, thank you. So there is no questions, just a confirmation. Perfectly. So well, right now we have our example application. So enter application ready to be compiled, and on the left bottom side of the Qt Creator screen, you can see that small icon of the microcontroller. Let's click that and let's select desktop and build in the release. Let's wait a bit to reconfigure the project. And let's click start to verify if our application will work on the host machine. All right, so as expected, we have our application running on the host machine directly from the Qt Creator. And as I said, it's a white rectangle with a text "Hello World" centered on the screen. And right now, let's switch the compilation target for the microcontroller. And to do that, let's go again to that microcontroller icon on the bottom left side. Let's click on it and let's select Kit STM32F769i Discovery and the build type release. And let's wait a bit to reconfigure the project. Okay, perfect. And right now I'm going to click the start button, and immediately I will switch the view to secondary camera to show you that exactly the same application will be flashed on our hardware. So I'm clicking it and I'm switching the view to secondary camera. Okay, so the application is right now compiling and will flash, and we have a question. I just joined since start time was 9 AM. I have Visual Studio installed, but automatically set Kit fails to compile the simple test program. Do I need to set up the MSVC kit manually? Oh, it's a hard question, I think. Let me just cover the hardware part, and I will try to help you. So currently, okay. So we see that on my side, at least, Qt Creator has flashed the board with exactly the same application. So let's get back to Qt Creator and let's try to solve your problems. All right, so let's focus on the first problem. Do I have to set up the MSVC kit manually? To be honest, I don't know the exact error on your side, but let's just verify the same thing. I will do that right now for you. So let's go to Tools, Options. And in the kits, please verify if you have the CMake 3.19.2. So it's just regarding the first question about setting up the MSVC kit. So please make sure that values that are here are also valid for your environment, and also please make sure that CMake tool is selected to 3.19.2 that is delivered together with Qt. And please make sure that you don't have any Qt specific things added to path globally in your operating system. So I guess this should help. The next question. If the main UI element, for example, the rectangle here is set to very small, how is the frame buffer filled? Well, so frame buffer then is allocated for the whole screen, and the rectangle will be drawn only on the part of frame buffer that that it can fill. So for example, if you have this screen that is 800 for 400 and your rectangle is only 100 on 100, then in the, well, let's say it's in the top left corner located, only this part of frame buffer will be drawn, but other parts of the frame buffer will be just garbage without any pixels drawn there. And another question, Qt Creator is complaining about CMake C++ compiler not being set. How should this be set? Please verify exactly the same thing as I said previously. So please go to Tools, Options, and in Kits, please verify that Qt for MCUs 1.9 for desktop, have the CMake tool selected to CMake that is delivered together with Qt. And please verify if that is exactly the same on your side, because it may be selected, it may be switched to the system CMake for some reason. And let's try again. Let's try again after verifying that. And if that won't work, please verify if you do not have any Qt specific things globally in your system in the path environment variable. This also could lead to some unexpected problems. And last question from you. It flashed the board for me, but I'm seeing black screen using STM-L4. Okay, L4. So please make sure that you have selected proper kit for your board, because L4 board will need different one. I do not have this one installed, so please make sure that as the first thing that you have installed the package for STM32L4 R96 probably, and please verify that you are using that one in your Qt Creator configuration to flash your board, because if you are using the different one, it has no chance to work simply. All right. So this is about running the application, at least the Hello World application, from the Qt Creator to the hardware. If you are still experiencing any problems, please let me know in the Q&A section. I will try to help you out. Oh well, probably there was another problem, but in the chat. Okay. Conrad has experiencing some problem with the CMake. Current configuration mixes C-Lang and MFC, so this is supported. Okay, so once again, this is please verify the thing with the CMake on the system, and please verify if your project is not using any other kits and targets than only Qt for MCUs targets. It could be possible that you have not cleared any other desktop Qt targets in the kits, and then it could lead to problem that you have pasted on the chat. So please make sure that you are using only kits that are marked with Qt for MCUs. This is a really important thing here. You have installed Visual Studio C++, but Qt does not see it. Please make sure that you have installed the proper version of Visual Studio C++. You have to install MSVC compiler with a version 1.4.2. Let me just verify that. Yep, MSVC 1.4.2. And also you have to install Microsoft Windows 10 SDK. So please make sure that you have those two things installed. Normally Qt Creator should detect those after your installation is is done properly. And also, please verify that you do not have any legacy versions of Qt added to path. Okay, there is another question. I managed to build one of the examples and flash it to my MCU, but I got an error message complaining about MSVC version too old. For my version is my version is fine, and it's the one you said. I solved it. I had to modify a MSVC header file. Is there a better way to solve this problem? It's a strange thing. Are you sure that you have installed the MSVC compiler from the Visual Studio 2017 or newer? It sounds like you could install the MSVC from, for example, Visual Studio 2015, and this won't work. Never. Okay. Well, it should work. So from my knowledge. Well, let me think a bit. What could be the problem there? Please verify if you have only that version of the Visual Studio compiler installed on your device. Maybe it can be Qt Creator could pick, for example, some different compiler that is also installed on your device. Jakub is also typing an answer for you. All right, so I hope that that you were able to solve your problems. Claudio, your problem is right now still under discussion with Jakub, from what I've seen. So please wait for the answer from him, and I will go further. If any more questions will appear, please, of course, feel free to ask those in Q&A section. All right, so this will be the first live coding session with Qt Creator. So let's see what you will learn there. So you will learn how to use built-in controls like buttons, sliders, and other things from the controls library. And you will also learn how to interpret compilation artifacts. You will see what are those and how they are looking. And you will learn how to use the CMake interface. Okay, there's another question. There was some misconfiguration in the defaults that I corrected, but it's now saying the current kit has no Qt version for desktop. What could be wrong? David, please verify that you have selected the Qt kit that is for Qt for MCUs. Please do not select any Qt kits that are for desktop Qt, for example. Please select only kits that are Qt for MCUs marked, so prefixed with Qt for MCUs at the beginning. All right. David, could you please tell me in which place you've got this message? Application output in here. Okay. Okay. Defaults are corrected, but the current kit has no Qt version for desktop. What could be wrong? To be honest, let me just quickly look on the options. There's no Qt version defined. Could you please create the project from the scratch, and well, so please close the Hello World project that you have, and then let's create a new one for Qt for MCUs, and let's verify if the message is still appearing. But for me, it seems like it's still picking something from the other kits. All right, so please just verify that twice, and please restart the Qt Creator if that's possible for you. As it really seems like it's still picking, Qt Creator is still picking some configuration from other kits than Qt for MCUs ones. So please verify those things, and let's try to fix that way. And I will try to explain what we'll be doing on this next live coding session. So the application structure that we'll be implementing in Qt for MCUs by using Qt Creator. So we'll have some splash screen to start our application. It will display some logo in there. It will share the background with the whole application. There will be a coffee selection screen to select some particular coffees. On that screen, we'll have also icons for some coffees. There will be a coffee selection language settings on the top left corner, which will display the pop-up for selecting the language and switching it and saving it, of course. There will be a history view, and there will be a coffee parameters. So after selecting one of the coffees, we will be able to change the parameters of the coffee. So we'll be able to switch between the coffee strength, some temperature, amount of it, and then we will be able, of course, to start brewing, and the simulation of brewing will be displayed as a progress bar in another pop-up. And all of those things will use the features of Qt for MCUs that I will explain to you. There will be a C++ integration at the end. And of course, there will be a lot of work around the assets, configuring the application, adding new components, and so on. And so this will require from you creating the new project. For those, okay, there is another question. Oh, this fixed the problem perfectly. That's great to hear. Still, for all of those from you that still have some problems, maybe you are still trying to resolve some configuration issues with Qt Creator. Please do not worry that much, because after each live coding session, you will be able to align with us, as there are special solution directories for each live coding step, by which you can then align in any moment, starting any new live coding session. So if you still experience some problems with configuring your Qt Creator, please take your time. You will be able to align with us by selecting a solution for the next step, and you will start exactly from the same place that I will be in. Also, please do not worry if you would like to follow those steps since the beginning, because you will receive the recording of the whole training, so you won't lose anything. Even if you are still trying to configure your environment properly remotely, it's a bit hard to solve of all problems. So, well, let's continue. Let's close the Hello World project, as we won't need that anymore, and let's get back to welcome screen and create new project. As previously, let's select application Qt for MCU. In the center, let's select MCU application, support application, choose. We will call our application Coffee Maker. All right, and let's switch the directory to training directory I prepared previously. So the same one that I'm holding everything as previously. Select the folder, click next. In the kits, this is a super important thing here to please check if you have anything selected by default. If you have, please unselect, and please select only the things that are marked with Qt for MCUs. And we are picking Qt for MCUs 1.9 desktop and Qt for MCUs 1.9 STM32F769i discovery bare metal with ARM GCC. If you have different board, you have to install and select different target for your hardware. All right, we are not going to use any version control. Let's click finish. And we have exactly the same application as previously. So the Hello World application with a white rectangle and the Hello World text in the center. And let's try to modify this a bit to start developing our application that is our coffee maker. And the first step will be to modify that rectangle to have the proper size. And width is 800 on 480. All right, we do not need the text with a hello world there, so let's remove it. And I will give some color for the background. It will be brown. And let's verify that our changes are making any effect. And to do that, let's select the kit on the bottom left corner. Let's click the MCU icon here. Let's select Kit for desktop and built-in release. We have to wait a bit to reconfigure the project by Qt Creator. And right now we can try to start our application. All right, so as you can see on the screen, we have a bigger screen right now, and of course, the background is right now filled with a brown color. So we can start developing our application from this state. We will expand our app with more and more features during the live coding sessions. All right. So maybe let's start from reviewing what's in our application structure. The first thing that our users will be seeing is the splash screen, and we are going to add this right now. Let's click on this hammer icon with the right mouse button and click Add New. We will add the new QML file. And in the Files and Classes section, select Qt. In the center, let's select QML file, Qt Quick 2, and choose. Let's call this file splash.qml and select Next. It will be created in our application directory. Finish. As you can see, okay, there is a question. Why are you using release target through your developing? Is this some requirement? No, it is not. It's just well, for convenience maybe, but every of you will see what I'm using. I'm just picking the release. We can also use the debug version for it. That's not a problem. You can use any of those, to be honest. Okay. So as you can see, after adding the file, Qt Creator has redirected us to cmake.list.txt file, and that's not by a mistake. It's just because Qt Creator is not modifying CMake files for us. So every QML file, every asset, and so on has to be added by us in the cmake.list.txt. And after adding it, it will just appear on the left side. And we just created this splash.qml file. So in the Q target QML sources, let's add that splash.qml to make it visible for our project. Save the file And well, it appeared on the left side. Let's open this splash.qml file. It's just an empty file with an item which is not drawing anything in the QML. It's just a container for other things. And well, let's try to modify that splash.qml file to provide some UI that will fit our design from the left side. All right, so okay, there is another question. Why there is special handling in your CMake with 1.7 version? Let me see. Well, it's just because from the version, it's automatic. It's generated automatically. It should be exactly the same on your side. But to explain, if Q version is equal or greater than 1.7, there is a Q at target macro available. Previously, there was not that macro, so we were forced to use the raw CMake macros for it, and the Q at target internally does exactly those two things. So it's just to detect if we have that API ready, and if we have, then we are just using Q at target. And if we are on the lower version of Qt for MCUs, then we are entering this part, and we are covering the things that are done in Q at target by a different way. So this is just a checking for the version to make sure that some CMake APIs are located there. So linking libraries explicitly isn't required anymore. For those two, no. We will be adding some other libraries in the next steps, but those two are linked by default always. If you are using Q at target, which is available from the 1.7. Okay, and there's some. Can you repeat how to add new file to the project? Sure. You have to click right mouse button on the hammer near the coffee maker project, and if you will click that right button on this, you are just clicking add new. Then you are selecting Qt on the left side and the QML file. Then you are clicking choose, and you have to just provide a name for it and click next and finish, and that's it. All right, so let's get back to implementing our splash screen. So we have just added splash.qml to our Q target QML sources, and let's open the splash.qml file, and let's extend this file with implementation that will fit our design. So we will need buttons, so we need to import controls for it. Import Qt Quick Controls. Version is skipped, but it's needed by Qt Creator, so it has to be some there. And well, this will refer to the previous question, I think. To use the controls, we have to link the controls library first. So let's get back to CMake list.txt, and let's link the controls library. I will do that here. So target link libraries, and I'm linking coffee maker with Qt Quick Ultralite Controls style. All right, and that's enough. Just referring to the previous question, okay, something is okay. I made a typo. Coffee maker. So just to align with the previous question, as you can see, Q at target does exactly those two things under the hood, and we are adding additional library in the normal way if we are have a need for that. All right, so let's get back to the splash. So currently we have imported the controls. We have linked the controls library with the default styles. And right now we can start implementing our splash screen. Okay, there is another question. Is there no IntelliSense support provided when linking those slips? No, unfortunately, there is no linking at this point. The support for Qt Creator is still improving, and it's still missing some things. Unfortunately, this has to be found in documentation, and you have to just simply write it with a hand. There is some simple IntelliSense support for the files if you are adding those, but not for the libs. But hopefully in the future it will be done. All right, let's try to implement this splash screen. Let's leave it to be an item to make it transparent, to share the background with the whole application. Let's give it some ID, root. We need some signal to notify the upper layers of the QML that someone has clicked the start button. So I will expose the signal for it. We will watch that signal later on in different components. And as you can see on the left side, the splash screen has two things, the logo and the button, and those are stacked one under another. So I will use column for it to lay out those two elements properly. This column I would like to align to the top of the parent. So top edge of the column has to be aligned with a parent. Parent is a constant property for all of the elements that always refer to the parent of a given component. So parent in the column will refer to the item which is the parent of it. And okay, and it's aligned to the top, and I would like to make some margin as well, top margin, and it will be 80. And horizontally, let's center that column in parent as well. All right. In the column itself, we would like to have some spacing between elements. So let's provide the spacing to 30 pixels. Currently, we don't know how to add any assets. So let's create a placeholder for the logo. We'll hold the place for our logo. Let's give it some ID, logo, size, width 60, 180. And maybe let's define some color, purple. All right, so for now it will be our logo, and we still need a button. Maybe. All right, we would like to have these buttons aligned to the center of the logo. So anchors, horizontal center. Let's align to logo horizontal center perfectly. Let's display some text in the button. Start. And last thing is to forward our event of interaction with the user. So if anyone will click the button, we will watch the signal clicked on the button component, and that signal handler will forward the event to our root clicked event, and we are calling it, and then we will be able to watch this clicked signal in the other components, and by doing this we'll forward the event to the upper layers. And right now we just defined how the splash screen is how the splash screen will look like, but we are not using that splash screen anywhere yet. And we are going to change that. And let's get back to coffeemaker.qml file. All right. And below the color property of the rectangle, I'm going to just simply use the splash. Let's give it some ID. Let it fill the whole screen. fill parent visible true. It's of course visible by default, but we will be manipulating the visibility of this splash screen. So to make sure that it's clearly visible, that this property will be changed, we are just passing some initial state for it. And we are creating a signal handler on clicked. And in this signal handler, we will just hide this splash screen. To enter our application. I think it's a good moment to verify our app. So we have desktop kit selected. Let's start. And as you can see right now, we have our splash on the screen. Currently, it displays the logo placeholder. We have a button. There is a spacing between those two items in the column. And of course, we have this top margin here as well. Let's verify if clicking the button will work. And splash screen disappeared after clicking the button. So everything right now seems to be working fine. Let's verify that on the hardware. So I'm switching the kit by clicking that microcontroller icon on the left bottom side. I'm switching to STM board, release build. Let's wait a bit to reconfigure the project and just click start. I'm switching the view to secondary camera. We still have that old Hello World application there. Let's give it a bit of time, still compiling the things. Okay, right now the linking process is ongoing. All right, and the flashing is done. So as you can see, we have exactly the same application running on the on the board. We can click start, and it works exactly the same way as on a desktop. Okay, we have questions. Does visible property control which UI element will be a part of frame buffer? Well, let me get back to sharing the screen instead of the camera. Well, does visible property control which UI element will be part of frame buffer? Well, in general, yes, but okay, right. So if you will disable the visibility for some particular element, it will cause redrawing of your app in the place that is affected by this change, of course. And I'm thinking how to answer your question, because it will, of course, prevent if you will disable the visibility. So then you're not rendering any elements that are invisible for sure. So then they won't be a part of the frame buffer, but the frame buffer will still keep the same amount of memory, as it will not change. So probably your question was about rendering, if that will save some rendering performance, for example. And question from the Claudio. I will reply. I will answer the additional question about the memory, but previously I will answer the question from the Claudio, as it was first. Can I have a debug session right in the MCU? Well, you should have. Let's verify that one. Okay. All right, I do not have the debug sources installed, so this won't be possible, I think. on my side at least. But in general, yes, it's possible, as the kit contains configuration for it. Yeah, there's a debugger attached. So if you are using the ARM GCC, toolchain selected for some particular kit, then the GDB is selected as debugger for it, and Qt Creator is able to detect that. With that one small thing, that you won't be able to debug the QML sources. You will be able to debug only C++ parts of your application. All right, and the last question, rendering, and how about memory? So, well, your frame buffer will be always the same. So after allocating the memory for the frame buffer in your application, it will be the same and will consume the same memory for the whole runtime. And by switching the visibility of some items in your application, you are not saving any memory. In fact, this will just prevent rendering some elements on this frame buffer. So by refreshing the parts with disabled elements, disabled components in your QML, it will be faster to redraw it, as there will be less items to redraw. So this will be improvement from that side. But about the memory, it won't save your memory. Maybe it could save some memory if you are using, for example, the compressed images that are located in the image cache and are loaded always on demand. Then by disabling such elements, you will save the memory, in fact. But in general, if you're asking about the frame buffer will stay the same during the whole runtime. So by just disabling some QML elements, you are not saving the memory for the frame buffer. For the platforms that are supporting the layers, I think it's a bit different. You can always modify the layer engine to for example, deallocate resources if you are disabling the whole layer. But this is the more complicated thing. In case when you have multiple screens in your app, all UI components of all screens are always in memory. Well, you're asking about, for example, if I have that splash screen, it translates to some C++ object for sure, and that C++ object will exist. Yes, during the whole runtime, whole rendering. So yes, this will consume some memory, even if it's invisible on the screen. The render tree will be initialized. Whole render tree will be initialized during the startup, and you cannot just simply discard the element and deallocate that during the runtime. How did create splash? So we created that in the previous step by clicking the right mouse button there and add new. Then I go to the Qt QML file, choose. Here you are providing the file name. You are clicking then just next and finish. File is appearing on the file is created on the file system. You have to add that file in Qt target QML sources here, and then you have to fill the things that are defining your splash screen. And in coffeemaker.qml, we are just using the splash component. The name of the component is always the same as the name of the file without the QML extension. And we are using that one in the root coffeemaker.qml here. Okay, so let's try to go further with those things. Jakub is also typing some answer for you. So wait a bit to more detailed answer, I think, and I'm going with the next steps with our live coding session. All right. So right now there is time to open the training materials that Jakub has shared with you previously on the chat. And let's review what's inside those. So you should have something similar to this. And the first application that we have created in the command line is located in the 0 first application. You can always refer to solution to get to see what exactly state was at the end. And right now we are focusing on the coffee maker. So one coffee maker step 0 is the directory that we are going to use in this live coding session. In the solution, there is a full solution of the whole live coding session, this one. That this is a state that we are going to have after implementation of this step. And the files are always the files that are prepared for us to save some time for doing exactly the same things. So all of those other QML files are created exactly in the same way I created the splash screen. They are using exactly the same components and mechanics. So we won't waste any more time to repeat those steps. We will just focus on learning new features and utilizing Qt Frames use parts to save some time. Before I will copy those files to our solution, I will answer some questions as I see that the chat is getting some messages. But first of all, Q&A section. The import Qt Quick Controls style default cannot be found in my include paths. All right, let me go back. It cannot be found probably because it's not Qt Quick Controls style default. It's just Qt Quick Controls to 0. But probably it could be related. First of all, it could be related to improper import. Just make sure if you have exactly the same. And the second thing, you have to link additional library. And I'm pasting you this part in the answer. So you have to link additional library to have those types available. And we are doing that by calling target link libraries macro from the CMake for the coffee maker target, and then we are providing Qt Quick Ultralite Controls style default library to link with. All right, let's look on the chat. Okay, I see that Jakub is talking with you on the chat, so the topics are well covered probably. All right, so let's get back to training materials. So as I said, in the files directory, there will be always files prepared for you to save some time and to just focus on the things that we are learning from Qt Frames use. We won't repeat the same steps each time for each component. Solution will contain always the final state of the live coding session that you can align with if you have any problems with following the steps with me. Let's quickly review what's in the files. We have new font. We have some helpers, helper QML files that will hold some margins, colors, and so on, and some components that are done in the similar way as the splash screen. So let's copy all of those. And let's go to our application directory, coffee maker, and let's paste all of those files there. All right, and right now we can get back to our Qt Creator, but there is another question. Oh, there is no question. That was just a mistake. Okay. Right, perfect. So we have added those new files from the training materials, and right now we have to add those new files to our CMake project to make those visible for our application. And first of all, I will add new QML files, and this is a back button .qml, coffee parameters.qml, coffee param group.qml, coffee selection.qml, coffee selection button.qml, and coffee param slider.qml as well. Let's save. All right. There is a question on the chat. No, there's just a thanks. All right. All right. So right now we have all new QML files added, and we have to add new fonts. Before, it's really important thing. Before adding QML sources, we have to add new fonts. And first of all, we have to tell which font we will be using. So set target properties maker properties tool default font family Roboto. All right, so we tell that we will be using a new font family, and right now we have to tell where this new font is located. So set property target coffee maker append property cool fonts here. And right now we will use one of the CMake variables, CMake current source tier, and we are starting with a $sign, then the curly braces, CMake current source dir, and after curly braces /fonts. And this directory is containing the fonts. It comes together with files that are our training materials. All right, we also have additional helpers modules, which are providing us some additional margins, some colors in separate QML files, and those are the singletons. And maybe you remember from the previous section of this training that singletons has to be located in the modules. So we are going to create a separate module, QL and QML module, and we will call it helpers module. All right, and let's define it. URI will be helpers, QML files, of course, our QML files from the helpers, in.qml, helpers, helper functions.qml. We will switch the output directory. Okay, and once again, $sign, curly braces, CMake current binary dir. It's a different one than previously. Previously, we had CMake current source dir. This is the CMake current binary dir, and after curly braces /helpers module, and generate QML types. All right. Well, in general, we'll also make something with the fonts to not with the fonts, with the import paths to make Qt Creator happy, just to make it visible. Tar not to set QML import path. And by doing this, we will prevent some error messages in the Qt Creator. So we are setting QML import path to exactly the output directory of the of the helpers module. All right. Cache empty string, and finally we have to link that new module with our application. So in target link libraries, I'm adding helpers module, which we have defined above. All right, let's try to run it on desktop. So let's switch the kit to the desktop one. Okay, some error. All right, there is some problem in the CMake. Cache path. Okay. Right now it should be okay. All right, so we have our application and nothing changed really. We just added new files to the application project, but we are not using them anywhere. So we are going to do this just right now and just verify what's going on in the chat. Okay, Jakub is helping you just there, so perfectly. Thank you, Jakub, for helping me out. It's a really active group today, but that's good. All right, so let's try to use those things that we have just added to our project to extend our application. Okay. Could you summarize what we have done? All right, sure. So we added files from training materials. So from the Coffee Maker step 0, I took all of the files from the files directory. I took all of them, I copied those, and I pasted them to our Coffee Maker the application directory. Then those training materials files were added to our application project in the cmakelist.txt. I added backbutton.qml, coffee parameters.qml, coffee parent group QML, coffee selection screen QML, coffee selection button QML, and coffee params sliders QML to our QL target QML sources. By doing this, I added new QML files to the project. I also defined new font by setting a property QFontsDir, which tells Qt for MCUs where our new fonts are located. These new fonts are coming together with training materials. So with the files I copied and pasted. And I also changed globally font family by setting QL default font family to Roboto globally for all applications. This is important to have those things above QL target QML sources to make it visible to our tools that are parsing the QMLs. All right, and then the next thing I done is to add the QML module to hold the helpers, which are the singletons in the QML. So I've added QL add QML module with helpers module with a given URI helpers with two new QML files from the helpers directory, team.qml and helper functions.qml, and I set output directory to CMake current binary dir helpers module, so I can then reference those artifacts, so the static library from this directory. And I also added some QML import path to make Qt Creator happy and to enable it to find our import libraries and to prevent some error messages in the IntelliSense. And finally, I added a new library to link. So in target link libraries where we previously were linking to default control style library, I also added helpers module, which is another library that holds our singletons with our helpers. So this is a summary we have done with the training materials for now. And right now I'm going to use those things in our application because right now we are just having those compiled in, but we do not have those used in our QML at all. So let's extend this a bit. So let's go to coffeemaker.qml file, and under the splash screen, let's add coffee selection screen to display the grid with the coffees to select. This screen is called coffee selection. It comes with training materials. Let's give it some ID. Coffee selection and uncourse. Let it fill the whole screen. Parent. And by default, it's invisible. All right. And if we will receive some interaction from the user, then we will know that the user has started the application, and then we would like to have coffee selection screen visible. So let's set its visible property to true. All right, let's try to run it. It's currently not possible to create a dynamic library to get the dynamic linking. All right, so this is our application. Let's verify if our coffee selection screen will appear after clicking a start. Okay, it's there. It's pretty ugly right now, so it misses some assets, but we will add those in the further steps. But currently we have our skeleton for selecting the coffee ready. So let's try to extend the application still a bit more to add the coffee customization screen. So after selecting a coffee, we would like to have the screen to show the sliders that will change the amount of the coffee and so on. So after under the coffee selection, let's try to add another screen, coffee parameters, with ID. Let it fill the whole screen as well. Okay, and well, this screen will have also let's see, coffee parameter screen will have the back button. So we would like to have a functionality of getting back to the previous screen. And right now I will watch the signal that holds the event of clicking of that button. And this signal is called back. So the signal handler will be on back. And if we are going back, we would like to be on the coffee selection screen. So make it still visible. All right, and coffee params should be invisible. Right. And also I would like to show the coffee params screen once coffee has been selected, and there is a signal that is triggered once user is clicking on any of the coffees that are displayed on the screen, and this signal is called coffee selected on the coffee selection screen, and the signal handler is of course called on coffee selected. And we would like to store selected coffee index and pass it to the coffee params. And coffee params screen, so coffee parameters screen, has a property prepared for that, and it's called coffee index. And we are just taking this coffee index from coffee selection screen, which has exactly the same property, coffee index. And right now, let's manipulate some visibilities. So coffee params should become visible. And coffee selection screen, coffee selection should become invisible. All right, this is a time to verify the application. All right, the splash screen, let's start the app and let's select the espresso. And I did something wrong. as we have a coffee parameter screen, but the coffee selection screen is not disappearing. So let's try to fix that. All right, coffee selection screen visible should be false, of course, after selecting a coffee. Let's verify once more. All right, let's start. Let's click espresso. And right now we have a pretty ugly as well coffee parameter screen, which can change parameters. As you can see, the index of the coffee is also properly passed as espresso is selected on the top right corner. Let's verify that with latte macchiato, and latte macchiato is passed there as well as an index, of course. All right, right now I would like to show you build artifacts of the things we have created. So I will open Visual Studio Code, and I will open our training directory. And let's focus on the build directories that are created by the Qt Creator. So we are interested in Coffee Maker. Well, let's select maybe let's compile it first for the board. All right. So I switched the kit to the STM32 board. I'm pressing start. Let's wait for compilation process to be completed. All right, so the build process is done. The board is right now flashing. I will show you the result later on, but first of all, let's focus on the on the build artifacts and what is generated in fact. All right, so CMake files, coffee maker, okay, right now let's review the splash.qml file. As I said you before, maybe I will open it and place it next to it. Every QML file is converted to C++ file on the by the Qt for MCUs. So let's find that auto-generated C++ file for the splash. All right, there is a splash.h, for example, which holds the struct that is called splash, and it inherits from the item, which is the root of our splash screen. It also holds the properties, exactly the same properties that our splash screen from the QML. So let's search, for example, for the signal clicked. It's there. It's converted to the C++ class, which is a template that holds some callable type. Also, let's try to find a column. It's there, so it's instantiated as a member. The star button and the logo is also there. Let's review the C++ side. For example, the constructor of this class. So as you can see, the column is set up. So the column child is appended. Of course, the spacing is set to 30, exactly the same way as in the QML. Some bindings are set to the anchors. The margin is set to 80 pixels there, and so on, so on. So everything that is located in the QML side is converted to something on the C++ side that will do exactly the same things. The same goes for the coffeemaker.cpp. So our root QML file is initializing the UI exactly the same way as for the splash screen. You can see that splash is initialized also there, and some properties that are set in the coffeemaker.qml are also set in coffeemaker.cpp in exactly the same way. One interesting thing is in the QL font cool font data and engines. So let's try to find some memory map. So currently we are using the strings for displaying some labels, and let's find some glyphs. All right, so currently I see that it probably uses the Spark font engine. Let me search for it a bit more. But well, the information about the glyphs is located also in some font engines directly there. After expanding the application, I will go back there once more to verify that every font is generated for the glyphs that are located in our application, and also each combination of the font type and size is defining another map of the glyphs to be used with. All right. So this is about the artifacts. And do you have any questions before we will go to the lunch break? All right, so this is end of the first live coding session. Just before going to the lunch break, I will show you how the application looks like on the device. So exactly the same as on the desktop. You can select the coffee. You can always switch the properties of it. You can go back and select the other coffee, like a latte macchiato, for example. Okay, there are some questions. It's also possible to send arguments to signals, and how do we receive them? Yes, it's a possible thing, and you are receiving them exactly the same way as in the JavaScript. So you are just defining this exactly the same way. And the second question, which files related to MCU ST files? Can I also demo that post-lunch? Well, I will try, of course, sure. But in general, we will cover signals and working with them tomorrow. So, well, I will see if that won't take too much time. But even if I won't cover that much today, I will for sure cover that tomorrow. But I will try still to give you some answers still today. Sorry, the last question I cannot understand. Which files are related to the MCU ST files? Sorry, could you write your question again? Then I will try to answer it. As currently I am not sure I understand what exactly the question is about. All right. Besides pictures, it's also possible to display small videos on the MCU. Currently not, and there is no support for videos. You can, there is some example how to display, for example, the feed from the camera, but in general, we do not have a support for displaying the videos itself in Qt for MCUs. And if you are going to show some animation based on the images, you can always create a bunch of the images that are decompressed during the runtime, and then you can use those as a kind of simulated animation frame by frame. But there is no native supports for the videos. So, okay, I think I understand right now a bit the question. So, first of all, the STM libraries are normally for the commercial license. You will receive the whole sources that are compiled with the SDKs from the STM, and those are located in the tools, Qt MCUs, STM, and there is a Cube SDK, and this is the SDK, or let's call it BSP, that you are using to compile your platform library for the Qt for MCUs, and that platform library is located. Sources for it are located in the Qt MCUs 1.9 platform, then boards, ST, and for the F769i board, there is a common directory with a configuration of the board and with implementation that uses all of other parts of the SDK and the well, let's say BSPs. So if that not answer your question fully, please share the exact question, detailed question with the sorry. Okay, I know what is the problem right now. All right. So once again, the sources for the platform that is using SDK is located in the Qt MCUs 1.9 and inside the platform, and then common, in the boards, and then ST. And for this STM board that I'm using, STM F769i discovery, in the common directory, you will find the board configuration files, for example, those. And then other files contains implementation that is using the BSPs and the SDK from the STM Cube. And that is also delivered together with Qt for MCUs. In the root directory, go to tools, then Qt MCUs, STM Cube SDK for the F7 family, and the platform is compiled with those sources, and with normal commercial license, you will have the full access to the sources, and you can then see which files are used from the STM libraries to compile the platform of the STM board. So right now you should be able to see those things I was showing you before. No problem. Okay, the next question: are dynamic libraries used in the target execution, or they are only used in the big Qt target? Only in the big Qt target. The MCU target is only using static linking. So there is a single binary that is flashed to the board, and the microcontroller is using that one, and there is no dynamic linking involved. So DLLs are only for running that host version. And the last question: is it possible to integrate STM libs to play videos? Which STM lib can be used? To be honest, I don't know which STM lib can be used for that, but for sure, if STM provides any libraries that can play videos, they can be integrated with Qt for MCUs. And for sure, the support of Qt for MCUs can help with providing such an example, for example, for this case. But out of the box, it's not supported. It's a custom thing, for now at least. All right, I see that Jakub is helping Konrad on the chat, but I don't see any more questions in the Q&A section, so I will slowly start our timer for the lunch break. And it will be 40 minutes. All right. So I will start the timer for the 40 minutes right now, and let's see each other after the lunch break. All right, welcome back after lunch break. Hopefully you're a bit more rest. So let's continue with asset management. To add any image to your application, you have to use Qt add resource. You have to provide the target, of course, for it. Then there is a list of the files with a prefix and a base, which can be used to manipulate your how you are referencing your files in the QML files, and the output directory, as always, to redirect your artifacts. And here's the example how to use the Qt add resource macro. So in my app, for my app target, we are adding res /image1.png file. And the file is, as you can see, located in the subdirectory res. And if we will provide base argument res, then in the QML, we can get rid of this argument, get rid of this directory, and we can just reference the image without this base. The prefix works in a different way. It's the opposite thing. So you can add something to force adding this part to the images, to the source of the images in the QML. And of course, you can mix those two. That's not a problem as well. So all resources have the properties. So you can set the Q compression, then the image is stored in the compressed format in your device. It will consume less memory, but the performance of rendering such images will be a bit lower, as it will require decompressing during the runtime. Q copy to RAM will mean that image, instead of being on the flash, it will be copied during the startup to the RAM for the faster access. Q image color depth is to override the color depth for the image. So automatically it will be stored in the best possible image color quality. And you can decrease that to save some memory in the flash and in the binary, or maybe in the RAM, by decreasing the value and the quality of the image by changing this property for the particular file. Optimize for rotation and for the scale are the kind of a flags that you can mark some images, and then the platform can decide what to do with those images to optimize for those transformations. And well, as I said, this is more like a flag, and it depends on the platform what will be done with those during the runtime. All of those also has default equivalence. So you can also define globally that all images can be compressed by default, all can be copied to RAM by default, and so on. So this is a short example of using the default. So this is the setting of default compression for all of the images, but still you can set for example, the background.png property Q compression to off, to exclusively disable compression if your default wish is to keep it enabled. And well, let's try to code something with the images. So let's try to add the images to your application, to our application. And what you will learn during this live coding session. So you will learn how to add resources, how to change file attributes, and you will see what is the outcome of a resource compiler. So what are the resources if it goes above bitmaps. All right, so let's get back to Qt Creator. And let's open training materials. All right. For all of you who maybe are lost during the previous live coding session, you can open step 0. So one coffee maker step 0, and you can take all of the things from solution. And this is exactly the state I have right now. So you can start following my live coding session by using this as a base. But for those who are in line with me, let's take step 1, so to coffee maker step 1, and let's go inside files, and let's review what files we have prepared for this step. So this is there is some update for helpers, some new functions in theme. We have resources right now, so some resources for the button, for coffees. We have 2 versions of logo, new background, and some updates for existing components. Let's copy those. And let's open Coffee Maker, paste everything here. If anything needs replacement, just please do this, and let's try to add those files to our application. So let's open cmake-list.txt, and after add target, so maybe somewhere there, we will add new resources by using qul add resource coffee maker. Files. Resources. Bottom back normal. All right, maybe let's copy. There is also a list of the files from where you can copy all of those. So I will do this right now. All right. And the base for it is just resources. All right. Let's replace right now the color with an image. So go to coffeemaker.qml. Let's remove the color, it's not needed. And let's put image there. ID is not needed, but we would like to have anchors. Which will fill the parent, and the source is of course qrc/main bg.png. Okay, let's change to desktop and play. All right, so right now we have a nice gradient under the splash screen. Let's review what changed there. So there was some update already to our coffee selection screen that includes right now the new small version of the logo. And as you can see, the background is shared through all of the screens. All right, let's right now modify the splash screen. We no longer need the rectangle, which is a placeholder for our logo. We can replace it with an image. Size and the color is not needed right now, so just let's provide source RC logo big PNG. Save the file. And let's review again. And here it is. So we have right now brilliant, beautiful logo in the center of this splash screen. Still, we would like to have images on our coffee selection screen, and we have to replace this what is currently there. But let's see how currently single button is implemented. So there is also a placeholder with a rectangle that is just colored, and the color is coming from the helper functions based on the index. So each index produce different color for the coffee, and we are going to replace it with, of course, with an image, and we will be selecting the source of an image based on index as well, in the same way from the helpers functions, but instead of returning the color, we will return the image address. So let's open helpers module and helper functions. All right, and let's find coffee selection button color. Here it is. So we would like to keep the same input argument and the same return type. And right now, I just need to replace the name, and instead of a color, I will return an image. All right. And based on the index, I will now return a different path. So magenta will be QRC cafe latte.png, QRC cappuccino.png, espresso, all right, and all right. Now in coffee selection button, I need to replace the property item color with a property image, which will be item image. And I need button image, which we have created. And let's replace rectangle with an image. Of course, size and the color is not needed. So just let's add the source, which will be item image. And we would like to provide some feedback for the user. So if the button is pressed, we'll decrease the opacity of an image by 50% to indicate the pressed state. And to do this, we will change opacity based on mouse. The mouse has a nice pressed property, which we can check for. And if it's pressed, it's the half opacity. And if it's not pressed, it's the full opacity. All right, and we can add mouse here as well. All right. Let's verify. Let's start, and the nice images are right now located on the screen. And let's verify if pressed state is working. It's working pretty good. But still, we do not have the logo here. We would like to have a small icon of the selected coffee, and the button back is not styled at all. So we will fix that. Let's go to coffee parameters screen, and we have to find out there is a prepared place for it. The source has to be taken also from helper functions. Get button image based on coffee index, and there is a question. How are these icon images positioned? All right, let me show you. There is a coffee selection screen, which is used on our root coffeemaker.qml. We are using coffee selection screen there, and it fills all of the screen. So right now, we are going to coffee selection.qml, and there is a row. So this row defines single Well, this row will define how items are laid out, and items are repeated by using a repeater there with a model free. So we have the 3 columns, and each column here have 2 buttons. And based on the index from the repeater, we are allocating new buttons, and this column is replaced by repeater 3 times. So we have 2 on the left, 2 on the center, and 2 on the right, placed in the row, one after another from the left to the right. So this is how those items are drawn. All right. Let's get back to coffee parameters. And right now we should be able to see the coffee icon on the coffee parameters screen, as we have added the call to the helper functions to retrieve the icon. And let's verify with Cafe Mocha. And here it is. So we have another icon of Cafe Mocha right now on the coffee parameter screen, and it will change each time for each coffee. All right, another question. Are the size values you use automatically scaled to match your target screen size? Well, this is application that you are seeing on my screen on the Windows machine that I'm running on the Windows is designed to fit the size of the screen on the board. Even if it looks smaller on the board, the resolution is exactly the same as on the screen as I'm showing you. So the STM device is running the screen 800 for 480, and the images are not scaled at all. They're just used in the format and in the size that are designed. So there's no scaling involved. All right, and the back button still is just a placeholder. So let's modify this a bit. So the root does not need to be rectangle anymore. Let's make it image with size. The color and the size is not needed. Just let's provide a source. All right. And let me just put that there. So depends if mouse is pressed, we'll pick different source. QRC, down PNG, and QRC, bottom back normal to PNG. Right, and well, so if mouse is pressed, so then we are displaying different asset than for the normal, and it will indicate that someone is clicking the button. Let's run it, and let's save, of course, and let's see the question. So how program is in a device-independent way? Well, so you can create a program that is device independent by, well, 2 ways. You can create an application that has different resolutions, of course, and you can have different sets of the images that are compiled differently for each device. And you can use the base and the prefix arguments of the let me show you Qt resource. So you can use different base for different images, for different devices. So for example, if you are compiling for the STM32F7699, you can have a different directory that holds assets for this board, and for different board, you can detect during the compilation process that you have a different screen, a different device, and you need a different assets for this. And then by just changing the base to different directory, you are changing the set of the assets to, for example, to smaller one. and then on the other device it will look exactly the same, and it will be laid out exactly in the same way, and proportions will be preserved by just changing the files. And of course, you can also scale the images, but it's not performance efficient, so probably it's not the way to go. And there is a question on the chat as well. If we enter screen image size wrong, what could happen? Then can we scale Mocha image size? Are those coffee images have to a special size? Okay. If you will provide assets that are too big for a device, then it will simply overlap the image. So you won't have the full image drawn on the screen. That's a simple thing. Of course, you can scale the image, and there is a possibility to do so. There is a transform property in the image in which you can provide the scale and rotation and so on. But normally you should have images that are designed for your needs. So you shouldn't have big images that you are scaling down for each device or in the runtime. So this is not how it should be done. From the other side, if you have too small images, you also don't want to scale this up. So as I said, this is exactly the same approach. So you need to have separate set of the assets for separate resolutions. This is how the MCU world looks like. You can scale some elements to make visual effects, but you shouldn't scale every image to fit different screen resolution. Then it will be not efficient, simply. Yes, there can be a special handling in CMake to select particular hardware platform. Yes, this is possible. You just have to check for the Qt platform that you are passing in the CMake. So, you probably remember this Qt platform. You just have to check for this and check if this equals or matches some pattern for you, and then you can set some arguments there, which then can be passed here, for example. All right. So there's a lot of talking, but I just previously, before I started the application, I modified it to have a back button style, but I forgot to remove the back string there. So let me fix that. Let's go back to back button and let's just simply remove the text. It's not needed. And let's start it again. All right, and let's review. Yep, and works as expected. If I'm clicking the button, it becomes white, and if I'm releasing the button or not pressing it at all, it's a normal state, so this beige thing, and it works exactly the same for all of the images, for all of the coffees. All right, let's see how it looks on the device. All right, application is flashing, so I will switch the camera. It's still the old content visible. Oh, well, it was not flashing, so it's still building the app. Sorry. The linking process is right now ongoing. Okay, there is another question. What are this image optimization for scale and rotation? How do they help? Okay, so in general, most of the devices, the simple devices, so usually most of the MCUs does not have anything special for rotation and for the scaling, for example. So the optimizations on those platforms are mostly moving the assets that need to scale and rotation, so need a lot of access to the data. They are just moved at the startup to faster memory. So usually such devices have some small amount of faster memory, even faster than a normal RAM, some special RAM, for example. And during the startup, such images are moved by the platform to this memory to make it faster to process the operation of scaling or rotation. On the more advanced platforms, usually in the automotive scenarios and in the automotive hardware, there are some specific image formats that are designed to optimize rotation or the scale, and then such optimization can be done by the platform or even by QRCC on the image processing step during the compilation to keep those images in the formats that are easier for the platform and for the hardware to rotate. Some platforms have also a possibility to rotate the images faster, but only in steps on some strict values, so strict steps. For example, you cannot rotate into the arbitrary value, but you can rotate faster to, for example, 90 degrees steps or 45 degrees steps. There are different things for different platforms, but usually on the low-end devices for typical MCU boards, the best optimization is to move those images that are marked to scale or rotate, is to move them to the fastest memory we have available on the board. But as I said, there are also other possibilities, but these are rather rare things, and these are rather designed for really specific cases and usually for the automotive sectors. All right, the board has been flashed with our application. Let's start the app, and as you can see, images are also on the board. And these are exactly the same images as you were able to see on my screen on the host machine. Oh, it's hard to click that. Let's verify if the opacity of the images is also changing on the device. It is. If I'm keeping it pressed, the opacity of the espresso icon is decreased to 50%. All right. Let's get back to sharing the screen. There is also one thing I have to show you. So all of those images are, as I said in the previous topics, previous steps of this training, each of the image is converted to the bitmap by default. And let's see something small, maybe logo small. As you can see, this logo has been divided to different parts, and these parts are just the parts of the image that contains any data that is not fully transparent. And finally, the whole texture is held as a list of arrays of the bitmaps, and Qt for MCUs does all the work for you to place those parts implicitly, and you are just operating on the single image. And this is the kind of optimization to cut off the empty spaces. But let's check for background, for example, and this is held in the single bitmap probably. And all of those bytes are defining our gradient for the background, and it's held in the RGB32 format without alpha channel of a given size. Everything is converted to the C++ ORIs. There is another question. Is touchscreen used always as a regular mouse within Qt for MCUs, or some special care must be taken? It's used as a regular mouse. So if the board supports touch, the reference board that is supported in Qt for MCUs, the mouse component will just simply take over all of the things that are related to touch itself. Exactly as you noticed. Of course, for the boards that are not supporting touch out of the box, the mouse component will not work. And there are some boards like that, and you probably can even create a product that has no touch. So then, of course, the mouse area won't work. There are some special gestures that are, well, for example, I think you are thinking about the swipe or something like that. Some of those are available, but for sure not all of them. You will find everything in the documentation. And I do not remember exact list of the gestures that are supported right now. But if you will go to documentation to Qt site, all of those are listed in the mouse area documentation for Qt for MCUs, of course, because this is a different documentation between the big Qt and Qt for MCUs. And another question, I assume the pre-processing of images into the C++ files and compilation can take a long time. Is it possible to put the images in the library of your program and use them in the rest to save on compilation time? Well, yes, it's possible. You just have to put your images to the separate module, and that should be it. So as we are creating the QML module there, we just have to provide some assets for it, and those will be available from this helpers module. But we will do that tomorrow on tomorrow's training, so you will be able to see how it's done. But well, those images are not recompiled each time you are compiling your application. These are processed and compiled only once until you change them. So this will work kind of incrementally. Probably it won't increase your compilation time if you are going to, oh well, maybe if you are talking about the CI, for example, this well, this could be helpful. Okay, right. All right. And if it goes about the assets, that's it. So you just have to know that by default, they are always converted to bitmaps, and this will consume more memory than the PNG on your device, on your host machine. So this is an important thing. And well, we are slowly getting to the end of today's training. So thank you very much. If you have any more questions, please ask right now. Regarding the signals question, I do not forget about this one. I will cover that tomorrow at the beginning, as I have to prepare some special example for you. And that will be probably the best way to do this instead of cutting topics today. Just starting from the fresh things. Tomorrow I will show you how to use the signals with the arguments and how to use those. But right now, please ask if there are any more questions. You can always write some email if your question is more complex. But if not, then thank you very much for today's training. You are really really active. This was probably the most active group we ever had. So thank you very much, Claudio. Okay, there is some additional question regarding this texture for small logo. I can see that this texture is marked as partially overlaps. Could you please describe this more detailed? Okay, the partially overlaps is some kind of internal thing that you probably, while developing your application, you won't have any need of manipulating with this. So partially overlaps just means that those parts that image is split into are partially overlapping themselves. So this means that Qt for MCUs can have to make some adjustments on the edges and on the coordinates of those parts to fit everything together exactly as it could be a single image. So this is just an internal information with the partially overlaps for Qt for MCUs engine to know that those parts will partially overlap themselves. So some of the pixels will be duplicated on the edges of those parts, and this should be somehow adjusted to of course not having duplicated pixels on the screen. So this is just an internal flag for it. Well, are there any more questions? All right, so thank you very much. If there will be any more questions, please write me an email. I will try to answer those questions as soon as it's possible. And if there are no more questions for today, let's see each other tomorrow at the same hour. Thank you very much, and have a great rest of the day. Goodbye.